Okay, we are doing more solving equations by substitution. So you should have turned in yesterday's 2 problems. And we are going to go through this problem. So go ahead and label the name on your next page. Substitution day 2. Slide 11. So we're solving systems by substitution. So let's see, what is that? So we have y equals 1 minus 2x, and 2x plus y equals negative 3. All right, so we are going to do substitution here. So we have what y equals. So we are going to plug in this for y. So that it's 2x plus y is now 1 minus 2x equals negative 3. Okay, let's look. 2x minus 2x on the same side. What happens to those? There's 0. So now it says 1 equals negative 3. Is that true? So what does that mean? Yep, no solution. When would a system of equations be no solution? Do y'all remember?
They're parallel.
When they're parallel. So my conclusion is the lines must be parallel. There is no solution. So if I were to solve this for y, I would move this 2x to the other side, and it'd be negative 2x minus 3. And this other one is really, if I rearrange that, negative 2x plus 1. So what do you notice about these 2 lines when they're solved for y? They have the same what? Slope. So that automatically means no solution. They are parallel. Okay, let's look at, so here, this is no solution. So we can just put on here, no solution. Okay, let's fill in the blank here. If you solve a system and the result is a blank statement, there is. So remember when we solved it and we came out with 1 equals negative 3? What kind of statement is that, mathematical statement? False. If it turns out to be a false statement, then there is no solution. If you solve a system and the result is a false statement, there is no solution. Okay, let's go to this next one. Negative 5x plus y equals 2. And y equals 5x plus 2. Okay, so that means that we are going to, what are we going to plug in? 5x plus 2 for y. Yep. So this would be negative 5x plus 5x plus 2, because that's your y, equals 2. We have a 5x plus a negative 5x plus a 5x. That equals 0. So all we're left with is 2 equals 2. That is a true statement. So what does that mean? It means infinitely many solutions. What will the graph look like whenever you have infinitely many solutions? Yep. One line. So that means these are the same lines. The lines are the exact same. So this one's already solved, right? Y equals 5x minus 2. If I were to solve this one for y, I would move 5x to the other side. And this one comes out to be 5x plus 2 also. They are the exact same line when you solve it. Okay, so we need to fill in here. I'm going to copy this so I can write it down here. Infinitely many solutions. Okay, if you solve a system of equation and the result is a true statement, then there is infinitely many solutions. There we go. Okay, so far we have done systems that have one of the variables solved. So we need to do some examples when a variable is not solved. They're both written in standard form. So I'm going to go to the next page because I don't have room on my other one. Solving with substitution. So this example is going to be negative x plus y equals 3. And 3x plus y equals negative 1. Okay, so it's a little different. We don't have a variable that's already solved for that we can substitute in. So what we need to do is we need to solve for one of the variables and then sub in. Which variable would be easy to solve for? X is negative x here, so no. And then this is 3x, so no. Y would be easy to solve on this one. So our first step is to take that one that's easy to solve for one of the variables, and that means get one variable alone. So we would just add y to both sides. Add x, sorry. And we're left with y equals x plus 3. So now that you have a variable solved for an expression, you can plug this in to the other equation for y. So our first step, solve for y. Next step, sub in expression. So now we're back to the rest of our steps as usual. So instead of saying 3x plus y equals -1, we're going to say 3x plus y is x plus 3 equals -1. Because this was y. And now we have an equation that only has x. So we can combine like terms, 3x and x, make 4x plus 3 equals -1. And now we're just going to solve for x. So I'm going to subtract 3 on both sides. 4x equals -4. Divide by 4. X equals -1. Okay, so we have one of the variables. Now we need to plug this in for one of these equations. We can actually plug it in over here too. So I'm going to say y equals x plus 3. I'm going to sub then the -1 for x. So it'd be y equals -1 plus 3. So what does y equal? Equals 2. So our solution to the system is -1, 2. Okay, let's do another one. Do you have any questions on that one? Okay, let's do another one. (2x minus y equals -5) and 3x minus y equals 1. Okay, so step 1 is to solve one of them for a variable. Which variable would be easiest to solve for? X or y? There's a coefficient for x, so I would say not x. I would say y. And both of these are -y, so it really doesn't matter at this point. So let's solve this one. You could solve the other one if you want, but this is the one I'm going to solve. So minus 2x minus 2x. So it's negative y equals negative 2x minus 5. But then we can't have a negative y, so we change it by dividing by 1 all the way through, which just really means that we're changing the sign of everything. So this would be y equals 2x plus 5. So we're going to plug in this into what? Into the one we just solved or into the other one? The other one. Y'all shouldn't be on your computers at all. You should be only on this, which is we're writing in our composition book. So we're going to plug in this for the other one right here. So now this is 3x minus, why is this whole expression? So anytime it's plus, I just wrote it out. But anytime it's minus or there's a number in front of that variable, I need to put it in parentheses. Okay, so this is just like saying a negative 1 out front, so we're going to have to distribute it. So it's 3x minus 2x minus 5 equals 1. Okay, so now we're solving for x. 3x minus 2x, 1x minus 5 equals 1. So we add 5 to both sides. So it's 1x equals 6. So that just means x equals 6. Okay, so we have the x value. Now how do we find the y value? Do what? Yeah, we're going to sub it in back in over here. All these arrows kind of make it crazy, right? So it's y equals 2 times 6 plus 5. So y equals 2 times 6 plus 5. What does that equal? 17. Yeah. So then our solution is 6, 17. And what I want you to do on your assignment is to double check your answers by plugging them in. So I'll go up here and I'm going to plug them in. So you need to practice this. It really doesn't take that long because you're not writing anything down. You're just subbing in the x and the y into each equation and checking to see if it's true. So let's go ahead and do that. Get out your calculator. This is going to be 2 times x, which is 6, minus 17. And then do the second math for test equals, is it negative 5? And so that's true. If it came out to say equals 0, then it'd be wrong. So 3 times x minus 17 equals 1. So that is true. So that's just an easy way to check your answers. So you should have done that with those 2 problems from yesterday. You can resubmit if you need to. The problems from yesterday, let me go ahead and give you the answers. I'm not going to show you my work. But the first one from yesterday was 5, 3. And the second one was 1, negative 3. So if you didn't do that, you can redo them and resubmit. So if you didn't get those 2 answers, then you need to redo it. Okay, I'm going to pass out today's assignment so we can look over that. Okay, so I'm going to show you the assignment so we can look at it together. So 1 through 3 just says solve for the indicated variable. So on number 1, you're solving for y. So you're going to circle the variable you're solving for and just solve it so you can get an expression. Okay, whenever you solve it, you do minus 8x. So I'm just doing a little check with y'all. And then divide by 4. This would be y equals negative 2x plus 3. So you'll have something with that variable equals some expression. That's how you're solving for that indicated variable. So the first one's done. Okay, 4, 5, and 6, it says, tell which equation you would use to isolate a variable. Explain your reasoning. So if it's already solved for a variable, then that would be easy to explain. So you're going to say either the first or the second equation, and then explain why. Okay, and then down here it says, circle the expression and the variable you can substitute in for the systems of equations. Then solve the systems of equations using substitution. You can use a separate sheet of paper because there's really not enough room here. So this would be considered 7, 8, 9, 10, 11, and 12. Okay, so you have the rest of the class period to work on this, and if you need help, I can come around and help you.